Okay, let's create a Copilot agent in Fabric. We are going to create an agent to chat with us about some sample insurance data. I've generated this sample insurance data with this Python script and run it in a notebook. The data has been saved into a lakehouse, and you can see that we've got these three tables here. We are interested in this customer table because we're going to be investigating a churn use case. So we've got this churn column with values of 1 and 0, 1 denoting that a customer has churned, 0 denoting that a customer is still with us. I have also created a semantic model. Microsoft has just changed the UI on this. Usually there's a button here that says view semantic model, but I now have to click write DAX queries and come at the bottom here where it says model view, where I can see the relationships being created, but you can see that there are some relationships here being created between these tables. So we can now create our agent to start chatting with our data. So I go new item, and if I search for agent, I will then see this data agent here. And if I click on it, I can then give this agent a name. So we'll just call it demo insurance agent, hit create, and we will now be able to configure our agent. I can see here that I'm being prompted to add some data sources. You can add data sources from different items in Fabric, such as the Lakehouse. We're going to add the semantic model as our data source. Now, as with most AI app development, there are performance considerations to take into account with regards to what information you give that agent and how that data is configured. So, for example, giving the agent the semantic model is explicitly telling the agent what relationships exist between the data. This will be a better performance when compared to giving it a lakehouse, where the agent will then have to make those inferences about the relationships between the data. So I've configured the agent to use these three tables within the semantic model. We can also give it further instructions. Now, the reason you would give it further instructions is for the same issue around performance that I was just speaking about. If I give the agent explicit instructions, it then has to do less thinking, and so we can expect some better performance. So like I said, our use case here is going to be around customer churn. So I'm going to tell this agent that the churn is represented by the value of 1. This is how you should calculate the churn rate, and also these are the columns that you should not look at when generating a response. So now that I've given this agent some instructions, I can then publish this agent. I can publish this agent available to people who also have access to Fabric. I can also publish this to the M365 Copilot store, where other members of my team can also use the agent in the M365 Copilot experience. So I've hit publish and my agent is successfully live. Now, to show you where I can use this agent is I can come over to Copilot on the left in Fabric, and I can then reference this agent by clicking the plus button, and I can see that this is the agent that I have generated here. So maybe I want to know what is the churn rate across these different policy types. And here we have a breakdown of the churn rates by policy types. But just in case that wasn't clear to us, I can just ask it again, which policy had the most churn and by how much? And here it's telling me that pension had the most churn with 31.11%. So there you have it. This is how you create a Copilot agent in Microsoft Fabric. In another video, I'll talk about how you can optimize your data in Fabric for AI, so to improve the performance of your agent. Let me know what types of agents you're creating in Copilot for Fabric, and also let me know some of the use cases that you're working on as well.